Hi all. From this video onwards, we'll be studying Newton's law and relative acceleration. And I'm thinking of going straight to the examples in this video because we are familiar with Newton's law, three Newton's laws, and how to apply them for simple problems. You have done so many examples in physics, so I don't need to introduce you to the concepts of F equal ma and all. So let's dig deeper into questions from the start. And first I will go through some simple examples so that I can refresh on Newton's law, how to apply them, the basic things, how to mark reactions and all. These things we will focus on, and after that we will get into our topic, right? So basically in combined mathematics, under applied mathematics, we will only focus on pulley systems and wedges, right? So wedges that can move on the floor. For example, a pulley system is this, right? A pulley system like this, right? This is a system of pulleys, right? So we have masses of this system, right? So if we let it go from rest, what will be the acceleration? What will be the acceleration of each particle? That's what we are going to study in this topic. And also wedges. By wedges I mean, right, wedges with a mass, right? This is similar to an inclined plane. In this case, we have two inclined planes, and also this can move. This wedge can move. It's not fixed, right? Inclined planes ganan hadaddi api danno inclined plane එක move වෙනවා කියලා අපි ගත්තේ නෑ. It's fixed කියලා ගත්තේ, right? Inclined plane එකේ උඩ particles move වෙනවා. ඒතර අපි inclined plane එකේ mass එකක් ගැනවත් මෙලෝදියක් ගැනවත් අපි හිතුවේ නෑ. අපි inclined plane එකට reactions දැම්මෙත් නැහැ. අපි particle reactions විතරයි mark කරේ. Reactions on the particle, weight of the particle, those things, tensions, that's what we marked. But in this section we have to mark reactions on the wedges as well, and masses of the wedges, acceleration of the wedges. මේ වගේ system එකක් આવොත් ඒව mark කරන්නත් ඕනේ. ඉතින් ඒ හින්දා අපි පිළිවෙලකට යන්. Basically there are for pulley systems, there's a technique that we can use using using calculus, right? So there's a technique that comes from calculus that we can use to get the acceleration. But before we get into that, we will look into some simple problems where we can mark the acceleration, guess the acceleration, and go ahead and do the equations. අපි ඒවා ටිකක් බලමු මුලින්. ඒතර මුලින්ම මම simple problems ටිකක් පටන් ගන්නවා. ඊට පස්සේ pulleys and wedges වලට යන්න. So before we begin doing examples, keep this in mind. Always consider acceleration relative to earth before applying F equal ma. Before applying F equal ma, you know that in F equal ma, A is the acceleration. So please make sure that acceleration is acceleration relative to earth. So method 10 මොකේ acceleration එකද කියන එක, acceleration of what, but always it must be relative to earth. මේක අපි ගන්න හේතුව තමයි අපි system of pulleys වල උනත් ඔයගොල්ලෝ දන්නවා මෙතන අපි M1 M2 කියලා ගත්තොත් we mark M1G and M2G like this. We mark them. මෙතන G is gravitational acceleration, so that is definitely relative to earth. මෙතන මේ M1G දාන හින්දා අනිත් හැම එකම relative to earth acceleration එක අපි ගන්න ඕනේ. අන්න ඒක තමයි මේක reason. Right. So now let's start with example 1. Right, so example will appear on the screen. A horizontal force F acts on a particle of mass 5 kg placed on a smooth horizontal table, producing an acceleration a meters per second per second. Find the value of F when A is 1.8 and the value of A when F is 12 Newton. Right. So it's very simple example. Please draw the diagram. there are two parts. For part A, you have some particle, right? Mass 5 kg. So mark 5g instead. 5 kilograms into g gravitational acceleration. So upward mark contact force. Contact force should come from contact. Medan mark R කියලා ගන්න. Right? So they apply a force F, right? Force F, and they say it will have an acceleration. Now for part A, acceleration is 1.8. They ask us to get acceleration 1.8, and they want us to find the force. May acceleration එක ගන්න මොන force එකක් ගන්න ඕන. So direction, show the direction. F equal ma. Force and acceleration connect karan F equal ma wali. Right? So force is therefore mass is 5 kilogram. You don't have to write units all the time, right? So in applied mathematics, A is 1.2 meters per second. So what is the answer? The answer is 9 Newton. Right? 9. Let's look at the other problem. Now in this case, they are asking us to find acceleration given F force is 12 Newton. F equal ma in this direction. So 12 equal 5a. Therefore A equals 12 divided by 5. So A must be what? 2.4 meters per second. 2.4 meters per second. Right. So let's move on to example 2. So example 2 is about a mass on an inclined plane placed on a force F acts on a particle of mass 8 kg placed on a smooth inclined plane of angle 30. So draw the inclined plane, 30 degrees angle, okay. Mass 8 එක දාපු ගමන් mg දාන්න 8g, right? 8 kilograms, right? So then you have to mark the reaction. May reaction එක, this is the reaction on the particle by the plane, right? तोर මෙහෙම ගත්තාම මේ පැත්තට reaction එකක් එන්න ඕනේ according to Newton's third law, right? तोर මේ reaction, this reaction is the reaction on the inclined plane by the particle. ඒ වුණාට අපි මේක අඳින්නේ නැහැ, right? මෙතනදී අපි අඳින්නේ. The reason is that inclined plane is fixed. When this is fixed, we don't care about its motion. How the force is over. I mean, in this section, we study why things move. We study why things move, right? What makes things move? How the forces makes things move. ඒ forces තමයි අපි study කරන්නේ. එතකොට දැන් මෙයා move වෙන්නේ නැහැ නේ, move වෙන්නේ නැති හින්දා අපිට එයාට force එකක් දාන්න අවශ්‍ය නැහැ, right? ඒ හින්දා අපි fix items වලදී forces mark කරන්නේ. If this is able to move, like in the wedges, in the case of wedges, smooth wedges, then we have to mark the reactions on that. Please keep that in mind. Make a simple problem. Mark. This is G. So I use double arrows. Right. Producing it an acceleration of 2 meters per second up the plane. මෙයාට acceleration එකක් තියෙනවලු 2 meters per second up the plane, up the plane, right? So usually දැන් මේක වෙන්න බෑනේ. මෙහෙම තියලා අතහැරියොත් මෙයා පල්ලෙහාට යනවා. එහෙනම් අනිවාර්යෙන් මෙයා උඩට යන්න නම් definitely there should be a force acting on this parallel to the inclined plane. Parallel to the inclined plane. Why? See this, F equal ma. A is a vector. F is a vector. A is a vector. මේ පේනවනේ මෙතනින් පෙන්නලා තියෙන්නේ මොකද්ද? This is a vector relationship එකක්. So you know that if two vectors are parallel to each other, we can write them as this. A is equal to alpha times b. If A and B are parallel vectors. මෙතනත් ඒකම තමයි දීලා තියෙන්නේ. මේ දෙන්නත් parallel vectors. M is a scalar multiple. M තමයි scalar multiple එක. එතකොට F and A acceleration එකේ තියෙන direction එකටම force එකක් apply වෙන්න ඕනේ. So let's call it F. ඒ direction එකටම තියෙන්න ඕනේ. අනිත් එක mass එක positive quantity එකක් කියලා කියන්නේ acceleration එකේ direction එක නම් තමයි force එකක් තියෙන්නේ. right? ඒ දෙන්න parallel වෙන්නත් ඕනේ direction දෙකත් එකම direction එකේ වෙන්න. right? okay. Find the normal reaction and the value of F. Take G to be 10. Right? They say take G to be 10 meters per second. So, normal reaction. This is the normal reaction. Sometimes we replace it with capital N. So, we have to find normal reaction and capital F. That's it. So, meter calling api danagannone weight taking component akkenawa resultant particle moves due to a resultant force. Right? Unbalanced force එකකින් තමයි particle එකක් move වෙන්නේ. balance වුණොත් move වෙන්නේ නැහැ. ඔන්න බලන්න දැන් මේ බලන්න. මෙහෙම දීද්දි මෙයාගේ weight එකට හරියන්න normal reaction එකක් දීලා තියෙනවා. So it is balanced. It is not moving. Particles tends to move, right? Tends to move. Particle they get an acceleration due to an unbalanced force. Unbalanced force එකකින් ද acceleration එකක් කියනවා. So මේ direction එක ගත්තාම අපි unbalanced forces mark කරන්න ඕනේ. First, let's find what F is. Parallel to the plane, parallel to the plane. F equal MA. May pen parallel here them, right? So this is 30. You know that. Then it's components. So let's mark F here. Metana mark for this F. Right? So may weight take component එකක් හින්දා මම බලන්න මෙතෙන්ට double arrows දැම්ම මෙතන එක arrow single arrow එකයි දාන්න. This should be 8g sin 30. And this component, main component should be 8g cos 30. Right? 8g cos 30. බලන්න. Okay. Right. එතකොට ඊළඟට F equal MA, so we have F in that direction and 8g minus 8g sin 30, that's all we have, is equal to m times a. Mass is 8 kilograms, so 8 into a is 2 meters per second. So therefore F is equal to this should be 80 into half plus 16, so 56 Newton. It must be 56 Newton. Right. Now they ask us to find the normal reaction. To find the normal reaction, then may F equal perpendicular to my normal reaction. So put F equal MA perpendicular to the plane. Plane eකට perpendicular දැම්මහම මේ F මෙලෝ දෙයක් කියන්නේ නැහැ. ඒක අපි perpendicular දාන්න. So then perpendicular. මෙහෙම plane එක තියෙනවා ඔන්න ඔහම පෙන්නන්න. Right? F equal MA. So we have R upward. May පැත්තට R, then 8 minus 8g cos 30. Right? Mass is 8. Acceleration. Do we have any acceleration in this direction? May පැත්තට කිසිම acceleration එකක් නැහැ. මේ particle එක මෙහෙම යන්නේ. මේ plane එකට perpendicular direction එකට acceleration එකක් නැහැ. Along the plane there is an acceleration. So no acceleration in that case. Therefore R is equal 80 cos 30 is root 3 by 2. Therefore 40 root 3 newtons. 40 root 3 newtons. Right. Okay. So let's look at another example. Right. So this question is about a lift. Right. Lift carrying a weight of 50 kilogram. Right. And it is carried by what do you call? Yes, cable. Right. It's a cable. They are asking us to find the tension in the cable and reaction on the block. Right, when the block is touching the surface of the elevator or the lift, there will be contact forces. Right, there will be contact forces. They are asking us to find the reaction. That means normal reaction on the block. Tension එකයි වැදගත්. So there are two parts to this problem. One is when the lift is moving up, the other when lifting moving downwards. ඒ දෙකේදී tension වෙනස් වෙනවද කියලා අපි බලමු. Why this is important? Now lifts are designed in this way. If you get into a lift, you would see on this side, right now, lift on this side, you would see that only 8 people are allowed, or 10 people allowed, or a maximum of maybe 1000 kilograms are allowed. මෙන්න මේ වගේ දේවල් දාලා තියෙනවා. හේතුව මේ කේබල් එක ඩිසයින් කරලා තියෙන්නේ they are designed to withstand such amount. එච්චර නෙවෙයි සමහරට safety factor of 2 safety factor twice safety factor එකක් තියෙන cables තමයි ඒගොල්ලෝ ගොඩක් වෙලාවට පාවිච්චි කරන්නේ. ඒතර ඒගොල්ලෝ මේ lift එකේ acceleration එක බලලා කොහොමද accelerate වෙන්නේ කියලා ඒකට අනුව තමයි මේ cables design කරන්නේ. මොකද you know that cables can only withstand a certain amount, right? Theoretically they can withstand infinite energy, infinite force, but in reality things will break. හරි ඒ හින්දා මේක අපි පළවෙනි එක බලමු. ඒතර මුලින්ම මම මෙතන මේ center of gravity මෙතනදී center of gravity එකේ මම මෙයාගේ mass එක weight එක මම mark කර ගන්නවා. that is 400 kilogram. so I mark 400 g. හරිද? then what I'm going to mark here is that I'm going to mark reaction on the block. Reaction on the block, let's call it R, and then weight of the block, that is 50 g. Now this is the thing, in the earlier problem that was an inclined plane that is not moving, but in this case the lift itself is moving. lift එක move වෙනවා. එතකොට block එකට lift එකෙන් reaction එකක් එනවා නම් R, there will definitely be a same reaction R, same amount R එක same amount එක මම මෙතන 50 එක, right? same amount මෙතන R මේ විදිහටම R අදින්න R, this should be 50 G, right? so I'll be an equal and opposite reaction. That's what Newton said, Newton's third law. Every action has an equal and opposite reaction. So if we have a contact force upward, there will be a contact force downward. So මේ R mark වෙලා තියෙන්නේ black color එකෙන් mark වෙලා තියෙන්නේ reaction on the lift by the block. Blue color එකෙන් mark වෙලා තියෙන්නේ reaction on the block by the lift, right? So keep that in mind, right? So let's look at the first part. They are asking us to find the tension and normal reaction, right? So they are moving with this acceleration. So මේ acceleration එකෙන් lift එක යනවා නම් block එකත් ඒත් එක්කමයි යන්නේ. දැන් ඔයගොල්ලෝ lift එකේ ඉඳි lift එක වෙනම යනවා, ඔයගොල්ලෝ වෙනම යනව නෙමෙයිනේ. ඕගොල්ලන්ට තියෙන්නේ same acceleration. So for the block F equal ma upward දැම්මොත් block එක විතරක් consider කරන්න. කැමති නම් මෙහෙම පැත්තකින් ඇඳගන්න. right? So we have 50 g and we have normal reaction R, and this is moving 2 meters per second. Draw it separately if you want. So මෙතනදී උඩට R minus 50 g equal m is in this case 50 kilograms. Acceleration is 2. So R is what? So 50 g we will take g to be 10 unot මෙයා 500 වෙනවා. This is 100, so 600 newton. බලන්න වෙනස. ඔයගොල්ලෝ මේක එක්ස්පීරියන්ස් කරලා ඇති. lift එකේ උඩට යද්දී ඔයගොල්ලන්ගේ කකුල් දෙකට බර වැඩි වෙන එක පාට. කකුල් දෙකට බර වැඩි වෙන්න හේතුව කකුල් දෙකෙන් on the foot there will be reaction, normal reaction from the lift on you, right? ඒතර සාමාන්‍යයෙන් අපි ඉඳිද්දි අපේ බර තමයි අපේ කකුල් දෙකට තේරෙන්නේ. lift එකේ උඩට යද්දී accelerate වෙද්දී එකපාරට බර වැඩි වෙනවා වගේ තේරෙනවා. අපි පොළොවට මෙහෙම තද වෙනවා වගේ. lift එකේ පල්ලෙහාට යද්දී අපේ ඇඟ නිකන් relax වෙනවා වගේ තේරෙනවා. මේක තමයි හේතුව. Usually if lift is not moving මේ part එක 0 වෙනවා, මේ part එක 0 වුණොත් R equal 50 g වෙනවා, right? If you are moving upward R එක වැඩි වෙලා පේනවනේ. හරිනම් 500 වෙන්න ඕන, now 600. So your weight has increased, right? ඔයගොල්ලන්ගේ weight එක increase වෙලා තියෙන්නේ මෙතන. හරිද? ඒක වෙන්නේ මේ acceleration එකකින් හින්දා. Right. So now tension. To find the tension, lift එකට දාමු. For the lift F equal ma upward. then මම lift එක විතරක් වෙනම ඇදලා පෙන්නනවා මේ ගානට විතරක්. then mark all the forces on the lift. So here we have tension. මෙතන tension එක මම අනිත් පැත්තේ tension එක mark කරන්නේ අපිට වැදගත් නැති හින්දා. then we have 400 g and we have this reaction R. Reaction R is also there. then උඩට T තියෙනවා. උඩට T පල්ලෙහාට 400 minus R we found to be 600 and mass is 400 into 2. This is 4,600 plus 800. So tension in that case would be 5,400 Newton. Right? Balance tension tension 5,400 Newton. Now we'll consider the same system when the lift is moving downward. Right. So I mark the acceleration downwards for the block. F equal ma, we can put it downwards. Acceleration lazy so we have 50g minus r equal 50 into 2, 400 Newton. Right. So earlier it was 600 Newton. Now it's 400. You can see it seems like your weight has decreased. Seems like your weight has been decreased. Okay. Now let's put lift F equal ma for the lift. F equal ma downwards. Let me draw the lift for the last time. One last time. You have tension upward. May tension 2 meters per second. 400 G. We have a reaction on the lift by the block as well. So we have R plus 400 G minus T equal 400 into 2. So in this case, T should be R is 400. This is 4,000. 4,400 minus 800. So tension in this case 3,600 Newton. 3,600 Newton. Right. So earlier tension was 5,600, I believe. 5,400 Newton. Now it's 3,600. Then බලන්න lift එක උඩට යද්දී මෙයාගේ tension එක වැඩි, පල්ලෙහාට යද්දී tension එක අඩුයි. ඒතර constantly මේ cable එක tension එක වැඩි වෙනවා අඩු වෙනවා, වැඩි වෙනවා අඩු වෙනවා. හරිද? ඔයාලට තේරෙනවද වැඩි වෙනවා අඩු වෙනවා? එතකොට මේ අපි කතා කරන fatigue කියලා එකක් ඕගලන්ගේ syllabus වල නැහැ. campus ගියාට පස්සේ මේ ඉගෙන ගනි. fatigue failures කියලා. So fatigue failures වලට මේක බලපානවා මේ alternate වෙද්දී, stresses alternate වෙද්දී. Right. So that's about it. Let's move on to the other question. So this question is about a tractor and a trailer. Tractor pulling a trailer with it using a tow bar. And we studied these types, similar questions under power, right? Power and energy. If you can remember, P equals FA and F equals MA. That's what we studied under that. So let's draw the diagram. We have a tractor of mass 800. So we usually use blocks to represent them. It's a simple thing, right? So this is a tractor of mass 800 kg. 800 kg. So we have 800 G, right? Then we have, and now in this case, let's use normal reaction to be N. Let's call it N1. For the trailer, you have 1,200 kilograms, so 1,200 G and N2. Now this tractor is pulling the trailer with a tow bar, I think. Tow rope, by a tow rope. This is a rope, so it would be under tension. So this comes under connected particle problems. When particles are connected, how can particles be connected? So in this unit, particles will be connected by strings. Strings වලින් connect වුණාම ඒ වගේ tension mark කරන්න ඕන. Right, so mark the tension. Right. And there will be resistance. There will be an exerting driving force. Driving force would be there 2.4 kilonewton. So mark 2,400 Newton by the tractor. Road resistance on the tractor and trailer is 0.2 newtons per kilogram. Per kilogram resistance dila tiyenne. So you mark them. Let's call this the resistance. Right, sorry. So road resistance, yeah, we can represent them here R1 and here R2. Mehamagari powers valadi R1 and R2. So road resistance would be R1 is a tractor, that is per kilogram. So we have to find R1 is this is 800 kilogram per kilogram, 0.2 Newton, right? Resistance is per kilogram, 0.2 Newton per kilogram, right? So R1 would be 160 Newton. Then R2, what is R2? R2 is 1200 into 0.2, this is 240 Newton. There we found R1 and R2. Then find the acceleration of the tractor and the tension in the tow rope. Acceleration of tractor means acceleration of the whole thing, because the tractor is pulling the trailer, so everything goes with the same acceleration. If the acceleration of the tractor is A, then the acceleration of the trailer should also be A. So when these types of problems, what we need to find acceleration and also tension, two unknowns. We need two equations. But in this case, tension comes in always pairs, right? So these are considered as internal forces. Whenever you have forces or reactions that comes in pairs, try to put F equal ma for the whole system. සම්පූර්ණ සිස්ටම් එකට දැම්මහම මේ t ට මේ t cancel out වෙනවා. අන්න ඒ වැඩේ. අපිට මුලින්ම acceleration එක හොයන්න පුළුවන් අන්න ඒ විදිහට. Now let's put F equal ma for the whole system in this direction. System for the complete system එකට දැම්මහම in this direction, what are the forces? 2400 minus R1 minus R2. What is the mass? System make a mass 1200 plus 800, that would be 2000 kilogram into A. So we found R1 and R2. 2400 minus 160 minus 240, 2000 A. This is 2400, this is 400, so 2000 equal 2000 A. So the acceleration is 1 meters per second. 1 meters per second. Very easy. Now you know the acceleration, so now we can use this acceleration value to find the tension. මෙයාට හරි දාන්න පුළුවන්. මෙයාට දැම්මොත් forces 3ක් තියෙනවා. මෙයාට දැම්මොත් forces 2යි deal කරන්න තියෙන්නේ. ඉතින් අපිට lazy trail එකට දැම්මනම්. So F equal ma for the trailer, F equal ma. In this direction we have tension minus R2 equal 1200 equals to 1. So tension is R2 is 240 plus 1200. This is 1440 Newton. So මෙච්චර tension එකක් දෙන්න පුළුවන් rope එකක් තමයි මේකට පාවිච්චි කරන්න ඕනේ. සාමාන්‍යයෙන් මේ සරුංගල් අරින නූලක් පාවිච්චි කරලා හරියන්නේ නැහැ. කොහුල අණුවක් පාවිච්චි කරලා හරියන්නේ නැහැ. අර ලොකු මහතල අණු දැකලා තියෙනවනේ. මේ නිව්ටන් ගාන විස්ටෑන්ඩ් කරන්න පුළුවන් string එකක් ඕගොල්ලෝ පාවිච්චි කරන්න ඕනේ. මෙහෙම තමයි design කරන්න. ඉතින් මේ simple examples. In practical world you have complicated design parameters. So this is just the basics of it. හරි. तो මෙච්චරයි මේ ටිකේ තියෙන. ඊට පස්සේ අපි තව examples වලට යමු. Then these are just basic examples I did. අපිට දැන් අවශ්‍ය වෙනවා ඊළඟට ඔයගලන්ගේ A level syllabus එකට එන ප්‍රධාන topic දෙකක්, that is system of pulleys and wedges. तर අපි system of pulleys වලින් පටන් ගන්නවා. wedges ගැනත් මම ඒ කියන්නේ system of pulleys වලින් example එකක් හෝ දෙකක් කරනවා. wedges වලටත් එකක් හෝ දෙකක් මම ඊළඟට කරනවා examples.